Hey guys, it's Mrs. Bryant. Welcome to your first flipped classroom video. I'm really excited and I hope that you keep an open mind. These videos are going to help teach you some concepts, but you can also go back and look at them later, so that way you have some tutorials options as well. Before we start, I need you to get your ISN out and make sure you go to the next blank page and you title it Solving Equations. If you do not bring your ISN home over the weekend, make sure you get out a sheet of paper and you copy everything we do down, and then you can transfer it to your ISN when we get to school. So, turn to your next blank page, title it Solving Equations, and press pause while you're doing that, and when you're ready to go, make sure you press play. Welcome back. Okay, so we're going to start talking about solving equations today. Solving equations is nothing new to algebra students. That is something that you learned last year in level 1 math in 7th grade, and I think you reviewed it again after the STAR test last year. So solving equations is nothing new. We will practice it some tonight, but before we get to it, I need to review you over what we did on Friday. Remember, on Friday we started with combining like terms, and to do that you would have to put everything that looks the same together, and I told y'all to circle it, all the x's, and you could put those together, and then I said to underline the constants. So it made it easier and more organized to look at. Remember, we have big old long equations that we can make smaller and look prettier by combining the like terms. We also talked about the distributive property. Remember, with the distributive property, you have something on the outside, so let's say 8, and then you have x plus 4 or something on the inside. Remember, with the distributive property, everything on the inside is being multiplied by whatever's on the outside. Okay, so we're going to practice that some more too during our flipped classroom video, but we're also going to be solving for x at this point as well. So let's go ahead and get started. This is your first example, so make sure you write it down. 4x plus 1 minus 9x plus 5 minus 17 equals negative 26. To me, that looks really, really, really long, and I want to make it look prettier, so when I'm solving, I'm not having to do 30 steps, I can do 3 or 4. So, to start with, circle your variables that can go together. I have a 4x minus 9x. Remember, 4 minus 9 would be a negative 5, and remember to bring that variable along because it's going to go for the ride until we need to solve for it. Once you have the variables taken care of, underline your constants. So I have plus 1, or positive 1, I'm sorry, plus 5 would be 6, minus 17 would be a negative 11, equals negative 26. Notice that I'm bringing my solution down every single time, so that way I know where I'm trying to end up. So at this point, I am trying to get x by itself. X is not by itself because of this negative 11. So in order to get rid of the negative 11, you do the opposite or the reciprocal. The opposite of negative 11 is a positive 11. So if I do it to this side, I need to do it to the other, so we're fair. That would be like giving first period $100 and not giving sixth period. That's not fair. So then you write everything that's left on this side. Negative 5x equals, well, if you don't know this in your head, take out your calculator. Negative 26 plus 11 is negative 15. X is still not by itself. It has this coefficient of negative 5. Right now, the negative 5 and x are being multiplied. So what is the opposite or the reciprocal of multiplication? Division. So I'm going to divide by 5 on both sides. And I have x equals 3. Now, to solve or to check to make sure that your problem is correct or you have the correct answer, you could put this in x1, or I'm sorry, in your calculator in y1, and put negative 26 in y2 and go to the table and scroll down to where x is equal to 3 and see if both of the answers are correct. Or you could do the long math and substitute in 3 wherever x is. Once you do all that math, you will see that x, or that this one expression is equal or equivalent to negative 26. So let's do another example. If you have not written down this example, make sure you pause the video and write down the example. Here's another example. Make sure you write it down, and when you're ready, we can start. Again, it's a really long expression with an expression on this side, and we want to show that they are equivalent, or we want to prove that when x is a certain solution that they will be equivalent. So to start that, you circle your x's. I have a negative 7x minus 2x, and you get negative 9x. Then underline your constants. 12 plus 8 is plus 20 equals 65. Now this should be easy peasy for you. I know I need to get rid of this 20. What's the opposite of a positive 20? Well, that's a negative 20. Negative 20 on this side because we want to be fair. So negative 9x is equal to 45. Solve for x, take the opposite of multiplication, which is division, and x is equal to negative 5. Again, stick this expression in y1, this in y2, go to your table, scroll down to negative 5, or I'm sorry, scroll up to negative 5, and make sure that y1 and y2 in the table are the same number. If they're the same number, you know that your answer is correct. Alright, make sure you have that written down. Here's your next example. Notice in this example, we have the distributive property. Make sure you are writing this example down so you have some things to go to on Monday when we start playing the game. So, first things first, distributive property. You distribute this 5 to each and everything inside the parentheses. So, 5 times x is 5x. 5 times 7 is 35. Plus 3 times 2 is 6. And 3 times negative x is negative 3x. Equals, notice I'm bringing our solution down, so that way I can solve for x at the end. So now circle everything that can go together when it comes to variables. 5 minus 3x is 2x. Underline your constants. 35 plus 6 is 41 equals 29. In order for us to get x by itself, the first thing I need to move is my 41. What is the opposite of positive 41? If you said negative 41 or thought negative 41, you are correct. Minus 41 on this side, minus 41 on this side. Those cancel out. You're left with 2x equals, well, 29 minus 41 is, if you don't know that off the top of your head, use your calculator, 12. And is it going to be positive or negative? Negative, because the sign of the larger number. Divide by 2, divide by 2. X is equal to negative 6. Again, check it in your calculator to make sure your solution is correct. Alright, what I want you to do now is to write this example down and hit pause. I want you to work this example and tell me if you come up with the correct answer. I'm going to go ahead and work it out now so that way you can check your answer. 7 times 3x is 21x. 7 times negative 1 is minus 7. And then this negative, or this subtraction sign, makes this 3 negative. So 3 times 5x is negative 15x, and negative 3 times negative 4 is plus 12, equals 53. Circle your x's with the sign so you don't forget them. So 21x minus 15x is 6x. Then you have a negative 7 and a positive 12. So it's plus 5 equals 53. Your ultimate goal is to get x by itself so you know what x equals. So to do that, you take away the 5 because it's positive. You take the opposite or the reciprocal. Those cancel and you're left with 6x over here equals 53 minus 5 is 48. Divide by 6, x is equal to 8. Alright, so now we're heading to a more what's the word I'm looking for? More difficult problem. What do you notice about this one now? this problem. You still have distributive property, but now you have a fraction. We're not afraid of fractions. We shouldn't be afraid of fractions. We know what fractions are as decimals. You can do it that way, or I'm going to teach you how to do it with the actual fraction. Still distributive property, so 1/4 times 8 looks like 1/4 times 8 over 1x plus, and then 1/4 times 1. So 1/4 times 1 over 1, because a whole number written as a fraction is just the number written over 1. Because if you think about division, 8 divided by 1 would still be 8. Plus 3/4 equals -3. So do the math now. 1 times 8 is 8 over 4 times 1 is 4x plus 1 times 1 is 1. 4 times 1 is 4 plus 3/4 equals -3. Now simplify your fraction. 8 divided by 4 is 2x plus 1/4 plus 3/4 equals -3. I don't need to circle that because it's the only thing I have left, so 2x. And then I have 1/4 plus 3/4. Well, 1/4 plus 3/4 is 4/4, or 1 equals -3. Need x by itself, so I take the opposite or the reciprocal of +1, and it's a -1. Do it to both sides to be fair. And you're left with 2x equals -4. Now, got to get rid of that 2, and that 2 is being multiplied right now, so the opposite or the reciprocal of 2 is division of 2. So divide both sides by 2, and you have x equals -2. I know that seemed like a really long and difficult problem, but it's not. It's everything that you know. You know how to add fractions, you know how to multiply fractions, you know how to do the distributive property. It's everything you know, so don't be afraid of the fractions. And then we're going to do a decimal one. It's going to seem easy compared to that one, especially when there's nothing to combine or to combine or distribute. So the only thing you need to move is this this positive 1.5, so take the reciprocal or the opposite. I just want to show you that decimals are exactly the same thing. 4.5 minus 1.5 is 3. Divide by 4, divide by 4, and x is equal to 3/4. So that is the end of our lesson. We will be playing solving equations on a roll on Monday in class. It's going to give you that practice you need doing what we just learned, but I'm going to be there to be able to help you instead of you having to do a worksheet at home and not being able to understand. I really, really, really hope you enjoyed your